Okay, welcome. Today we're going to be working on some examples with triangles and their interior angle measures, some multiple choice involved, kind of taking a look at, um, you know, what we're given in the question and then how we use that to solve for what they're asking for. So a couple key pieces here is we're given an isosceles triangle. They're even giving us that by giving us equal measure of 20 and 20 here. So what that tells me right away is that these two angles here at the bottom, because they're opposite sides of equal measures, that these angles will have to be equal. So these two angles will have to be the same here and here. When they talk about vertex angle, they're generally referring to the angle that is connected to both equal sides here. This here would be your vertex angle. And it says it measures 24 degrees and two congruent sides, 20 units. They want to know what is the measure of these base angles. These here, they are our base angles. And all I need to do is take the 180 degrees that's within every triangle, subtract the vertex angle, and then split that into two angles, and it would give me 78 degrees, meaning both of these angles here and here, if I wanted to equal 180 degrees, and I want to keep the fact that if these sides are equal, these angles are equal, both these angles would be, in fact, 78. Here's another good question. Just kind of, they're not giving you that triangle, but like I mentioned to you guys quite frequently, it is important to draw a diagram when you guys are trying to come up with an answer. And in this one, they're giving us angle A, B, and C. So all I need to do is list that angle A is 23 degrees, angle C is 18, and I know that a triangle adds up to 180 degrees, so I'll add the 18 plus the 23 and solve for that missing angle of 180 degrees. Add these two together. What I like to do is 10 plus 20, 8 plus 3, so I have 30 plus 11, and so I have 41 plus x equals 180. And then subtract the 41, x is equal to 139. And this is my angle here that I'm missing. Simple, but they're just doing it in a way where they're giving you a missing angle there. Find the value of x. This is a great question. Remember last semester we talked about linear pairs, supplementary angles. So even if you look at this angle here, this 122 degree angle, the idea is that these two angles make up a half circle. They're supplementary, so they're equal to 180. So this angle here is 58 degrees because both of those would add up to 180. So here's my 58 degrees. I have another supplementary linear pair of 86 and call this 94, which would be this angle here. And what this allows me to do, anytime I'm given two angles in a triangle, 94 and 58, I can always solve for the third. And again, I like to show you what kind of math I'm doing in my head. 90 and 50 gives me that 140. The 4 and the 8 give me that 12, so I could simply just say this is 152. Keep in mind, they are giving you this answer of 152 here, but that's not what they're asking for. They're asking for x. So subtracting that 152 gives me x is equal to 28 degrees here. Next question. This is a good one. One of the tactics we learn in our SAT class is to add a line to the diagram. So that's what we want to do here. That makes this question quite easy. You have this line here, and it now transforms this diagram to a triangle. This one angle here is 130 degrees. this one angle here, they're giving me 33 degrees. Again, we're kind of revisiting that idea that this is a 130-degree angle, making this a 50-degree angle. And here we have the two angles that we need in order to find this third. 50 plus 33 gives me an 83-degree angle. So I know that other angle needs to be 180 minus 83, 97 degrees. Continue on. This is another one similar to the first question we worked on, but the difference is here is that, like I asked you to do in the other one, that you guys come up with your own diagram, making this vertex angle 24 degrees, and then the two congruent sides here 19 and 19. So basically we've been able to draw a diagram similar to we've been able to come up with a diagram that's similar to the triangle here, 19 and 19. And now we're working on our base angles here, x and x. And here you have 24 degrees with two congruent side measures of 19 units. And I know these two angles, so I can actually show you guys how to write this as a different equation this time around, where if I have 2x, x plus x, I could call that 2x plus the 24 is equal to 180, minus the 20, minus the 4, and we're here at 156, so 2x is equal to 156. And if you see, just like the same question or the first question we worked on, you end up with the same measure, but this is a instance where you have to have an understanding of vertex angle and kind of come up with your own diagram. We worked on this one. Something I actually want to show here, I almost don't want to go over this question, but you may end up with, let me show you another one here. You may end up with a question where it asks for this angle here. And I want to show you something about exterior angle measure theorem. So basically, let's say this angle here was 80 and this angle here is 20. If you add up the two remote interior angles, so the two angles furthest or that are not touching this exterior angle here, if you add those two up, the 80 plus 20, and you get 100 degrees, that'll actually be the measure of this angle here. And let me show you why that is and how that allows you to skip a few steps. So I don't like that. So let's say we have the 80 and the 20. Now convention tells us, okay, let's solve for this angle here to get this exterior angle here, because that's a linear pair. Now, if I'm adding 80 and 20, it gives me 100. Now, I take that 100, I subtract it from 180, and I get 80 degrees here for this angle here. Now, take the 80 degrees, subtract it from 180, and I end up with 100. Like I did here, right? So what ends up happening is we add these two angles together to subtract from 180, just to go back and subtract that from 180 again. So the relationship kind of looks like, if you were to make it a formula as such, is that your A plus B will always equal your C here. These two angles here will always equal your C. And let's say I had a D and an E here. These two angles, if you want to look at it, A and D will equal this angle here of E. And let's say I had another angle measure here. Let's say call this F. And I just looking at, okay, A is connected to F, so I want to look at the two remote interior angles, the two angles that are away from F. And I would say D plus B would equal to F, would be equal to F. So in geometry, this is called your exterior angle measure, which I've just kind of done a quick side lesson on, but would be helpful in questions. This is a common question that students have a difficulty with. the most important piece of information is here. RS is congruent to ST. And it tells you SRT is 4x minus 36. Now, what the isosceles triangle, by them telling you it's an isosceles triangle, giving you this SRT angle here, is basically tell you whatever this angle is here will be the same here. So we could also call this 4x minus 36. And this angle here is 4x minus 36, and they tell us STU here is 8x. And there's that visual again of a line made up of two angles, and we know this to be a linear pair, so we end up with 12x minus 36 is equal to 180. We can add the 36. 12x is equal to 216. Divide both sides by 12. X is equal to 18. So again, this kind of reveals to you, or it does reveal to you, that the triangle is isosceles, which then in turn tells you that whatever this angle is will be this angle here. And then last one, this is probably one of my favorites, one you'll see most common at SAT. It has a few steps in it, a few ways to solve for this. You know, you could look at this angle here and here, add these two together, subtract it from 180. That's the 28 and the 64 I just added. And you get your 88, which makes this angle 88. Now, what that allows me to do is eliminate two answer choices. I always like to do that on any sort of test. Here, now the x, so we had 28 plus 64 plus x equals to 180. The next piece is that x plus y is equal to 180, because that's a linear pair. So I have x, which is 88, so subtract that from 180, and we have y is equal to 92. And then continuing on, we look at, okay, now we have y, so let's look at the fact that y plus z plus 23, this is a z here, is equal to 180. We know y is 92 plus the 23 plus the z. That gives me 115 plus z is equal to 180. So then we have, subtract the 115 from 180, and you end up with z is 65. So this is a good one, because it basically, you're using three separate x to get y and y to get z. So there's three separate, we should have said here x was 88. You're using three separate equations, and this is what you'll see very commonly on an SAT type test here. And that should do it for today.